ogives. We're still talking about quantitative data. Time plots are exactly what it says. We're looking at plots according to time. And ogives are a little bit different. It's something called a cumulative, meaning you keep on adding up, you accumulate, relative frequency. Well, what is relative frequency? Well, that's percents. So you keep on accumulating percents until you get to what? 100%. Okay. So let's talk about time plots here. In time plots, we have some vocab. There's something called trend. If I have a graph like this, the overall trend, if you go from beginning to end, is increasing. If it was going down, it would be decreasing. Okay, obviously it goes up and down, but overall, from beginning to end, it is increasing. That's the trend. Seasonal variation. Now, different things happen at different seasons. So if you're a farmer, you know, your crop is better during a certain season than it is a other part of a season. And so that's why they call it seasonal variation, because sometimes it peaks and valleys at different parts of the year. Okay, or time period, whatever it may be. So, the seasonal variations are this right here, and this right here. Look at, they're peaking here. Okay, might be different parts of the year. Something may be causing it to peak there. But just like it's peaking, it's also dipping down. Okay, it looks like over here. So they have seasonal variations going up, going down, going up, going down, going up, going down. Okay? So going across here, the overall trend is increasing, and we have seasonal variations of peaking and falling. Not so much on the first one, having seasonal variations, but we really do here. Okay, so let's look at an example of a time plot. We're looking at Roman numeral number 6. And A was trend, B was seasonal variation, so we're looking at C. And C is life expectancy. Against year. Year will always be your X data, if you would. And we got year 1900, life expectancy is 48.3. We have year 1910, life expectancy is 51.8. Dot, 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 all the way to 2000 and 79.5. So we're not going to start off at year 0. We're going to start off at 1900, 1910, 1920, 1930, 40, 50, 60, 70, 80, 90, 2000. So down here, this is years, or year. On the y-axis is what we're talking about. It's life expectancy. And that's in years. We're going from 48 to 80. So you probably don't want to start off at 0. And what am I going to, I'll scale by 8s. 56, 64, 72. Could go a little bit more space here. 48, 54, 62, 48, 56. I can't add. 64, 72, 80. There we go. Give it a title. Title is life expectancy. And for 1900, we have 48.3, 51.8. We connect them. 54.6. 61.6, 65.2, 71.1, 73.1, 74.7, 77.5, 78.8, and 79.5. Now, if you have to describe, we look at trend, we look at variation, so on and so forth. The overall trend in life expectancy is increasing from 1900 to 2000, but seems to be leveling off at about 1980 to 2000. Okay, pretty easy. Okay, ogive. Ogive, just like what I said, is a cumulative relative frequency. One thing, you cannot determine how much data is in an ogive unless they tell you. So we're looking at 7C. And I said the following is an ogive on the number of ounces of alcohol. 1 ounce is about 30 milliliters consumed per week in a random sample. Part A. I'm going to say, what is the percentile at 11 ounces? So what you do is, you go down at the bottom, at the x-axis, go between 10 and 12, 11, go up, and then go to the left, and then when you go to the left, it's a little bit above 60, so it's about 65%. Part B. What number is in the middle? Middle number is 50 percentile. It's also called the median. So you go to the y-axis, go to 50%, then go across to the right and down, and you get about 7 ounces. Top 15%. How many ounces are in the top 15%? So really, you look at 100 minus 15, which you look at the 85th percentile. So you go up on the y-axis at the 85th percentile, so a little bit past 80, and then go across, and then straight down, and you get about 16 ounces. And then part D, between 2 and 8 ounces. Between 2 and 8 ounces, well, you go on the x-axis at 2 ounces, go up, and you find out it's about 10%. Do the same thing with 8, you find out it's about 60%, and then you subtract them. And you get about 50%. So that is the basics in an ogive. Okay? And there's some little more other stuff we can do with it. We can make a histogram with it. We can make a box plot with it. And I'm going to show you how to make a box plot with it when we get to box plots. Okay, good luck. Those are your time plots and ogives. Please remember your ogives are cumulative relative frequency graphs. A lot of times they have those good multiple choice questions. And time plots, make sure you label your axes correctly. Good luck.